Hello and welcome to today's class. So we are going to be handling simplification of surds, as this is knowledge that you need before we go ahead and start handling operations concerning our surds. So under simplification of surds, there are two general rules I want you to know. All right. So the first general rule is that whenever you are having a surd, of course, which is a composite number basically is a number that is made up of two factors. All right. So whenever you have a surd that is made of composite numbers, let's say xy, we can always rewrite it as the surd of x times the surd of y. So either way, these numbers will always have the same values. And so the other thing I also want you to note is that when you also have a surd of a fraction, say x all over y, that this is always going to be the same as the surd of x all over the surd of y. There's no difference between these two. And so an important note that I also want to put across that I think you should know is that all surds are said to be in their simplified form if the number below the root sign is a prime number. And so this is what I actually mean. So when you have a situation where, let's say, we have the root of x there, then we say that this surd is in its simplest form only and only if x is a prime number. So that's said and done. Why don't we do a couple of examples, then we see what we actually are talking about. Okay, so we have a question here. We are supposed to simplify for the first part of the question, the root of 28, and the second part, the root of 216. And so this here is a surd, okay, same to 216, and we're supposed to simplify the surd of 28. So when you're simplifying surds, I want you to think of one thing, all right? I want you to think of one thing. Think of a number. And it has to be a square that you can, it has to be a square and it has to be the highest square that you can actually divide 28 with. So in talking of squares, we're talking of numbers that are multiplied by themselves, okay? The product of numbers we get when you multiply a number by itself. All right, so when you take 2 by 2, of course, you get 4. So that's the lowest square we can talk of. That's the second lowest square that we can talk of, right? So anyways, you look at 28 divided by 4. And of course, it gives a perfect quotient, that is 7. Okay, the next square after that, it happens to be 9. Okay, so 28 divided by 9, yes, the quotient is there, but it is not perfect, and so we're going to settle for 28 divided by 4. Okay, so we're going to rewrite 28 as a composite number of what, of 4. All right, so we're going to write 28 as a composite number of 4. So this is how we're going to basically do this. So we're going to have the surd of 28 rewritten as the surd of let me have the whole thing. Let me have the whole thing here so that you are able to follow what I'm talking about. So we're going to have 28 written as 4 times 7 first. Okay, we are going to have 28 written as 4 times 7. So 4 here is the square that we are talking about. All right, and so we have 7, which is a prime number, and that is what we want. Okay, so then we're going to have this rewritten as the root of 4 times the root of 7. You can remember this from the first note that I gave, that whenever you have a composite number xy, you can always write it as the product of x and y. So basically, the product of 7 and 7, 4 and 7 here can be rewritten in that particular manner, of course, in surd form. And so we all know that the square root of 4 is 2, okay, times root 7. And so we can always simplify this to 2 root 7. 2 times root 7 is 2 root 7. And so this here is the simplified form of the surd 28. All right, so we are done with A. We're going to do B. The same concept applies. So you think of a square that we can, it has to be the highest square that we can multiply the number 216 with. Okay, so we can start with 4. 216 divided by 4, we get a perfect number, a perfect quotient, which is 54, which is good. Okay, so we go to the next one, 216 we divide it by 9. Okay, so we still get that 9 can divide 216 and gives us a perfect quotient, which is 24. All right, so 216 again. The next square after that is 25. 216 divided by 25. Yeah, it doesn't give us a perfect quotient, so we won't settle for that. So 216, however, divide by the next quotient after 25, which is 36. We get 6. Okay, we get 6, and I think we can work with 6 there. Okay, because the next one is 20, happens to be 49, and when you divide that, it doesn't give us a perfect quotient. So basically we're going to rewrite 216, the surd of 216, as a composite number of 36 and 6. So 36 times 6 will give you 216. Of course, we already know that we can rewrite 36 here as the root of the 36 by 7 as the root of 36 times the root of 6. All right, so we know what the root of 36 will be. All right, the root of 36 will be 6, of course, times root of 6. But I want to also submit to you that for us to say that a number is actually in the simplest surd form ever, it has to be a prime number, and 6 is not a prime number. So we're going to rewrite 6 using its two factors, which is 2 and 3. So notice we are going to have 6 times root 2 times 3, which we can break into 6 times root 2 times root 3. Okay, so when we multiply all of this together, we get 6 being equal to root 2 root 3, and so that there is the simplest form of the root of 216. So that is how you actually deal with these things. Okay, that is how you actually deal with these things. I'm going to handle a bonus example on this, then we move on to something else even more important. Okay, so let's go ahead and handle these two bonus examples and see what we get. So we're supposed to simplify x squared y, and of course the surd of x squared y and the surd of a raised to 4b squared c cubed. All right, so let's look at this here. So again, we're going to think of the highest square that we can actually use to multiply. We can actually use to divide this composite number x squared y squared to get a perfect quotient. Of course, that is in the answer. So that is given in the question itself. Okay, so that quotient. Sorry. Yeah, right there. So that perfect square will actually be x squared. So we're going to have x squared times y. Okay, x squared times y, which I said we can always write as x squared and by y. And so note the square root of x squared is going to give us x times the square times the surd of y. Of course, when you multiply x by the surd of y, you're going to get x root y, and that is going to be the simplified form of that particular problem right there. And so let us handle this last example here, then we move on to something else. All right, so again, when you're thinking of these things, you want to think of the highest square. You always want to think of the highest square. But looking at this particular problem here, it's kind of special because we are having I can just have it the way it is. We are having a raised to 4 and b raised to 2. So basically what we're going to do, we're going to rewrite these number as, in terms of its composite factors. But what we're going to do is we're going to make sure that the powers are all even. Okay, we are going to make sure that the powers are all even, so when we're finding the square root, it's easy for us. Okay, so to rewrite this, we are going to have it in this form. So it's going to be a raised to 4, okay, times b raised to 2, okay, times c raised to 2 times c. So basically c was raised to 3, but I'm having it now as c raised to 2 times c. So you see, I haven't changed its value, it's just the same number, but now I'm trying so much to have all the factors there raised in an even positive number. An even positive number, of course, and then it becomes easy to find the square roots of them, of course. So we can always rewrite this as a raised to 4, the surd of a raised to 4 times the surd of b squared times the surd of c squared, of course, times c. All right, so the root of a raised to 4 is going to be, that is basically 4 divided by 2, okay? It's going to be a squared, okay, times b raised to 2 is going to give us 2 divided by 2, that is a power. It's going to give us b times c raised to 2. Basically, if you're finding square root, because it's over the 2, again, we do the same thing. It's going to be 2 divided by 2, and that's going to give us c, okay? Sorry, this should have been root c, okay, times root of c, because we cannot find the square root of c right there. We cannot find the square root of c right there. Okay, all right, so we are going basically to multiply all these, and so when you multiply this, is going to get, we're going to get a squared b c root c, and of course that there is going to be the surd of that particular problem. So for our next example, we are going to handle a situation where you are given a surd in its simplified form and you are told to rewrite it back to its original form. Let us handle an example and see what we get. All right, so for our first problem here, we have a situation where we're supposed to express these surds a and b as a square root of a single number. Basically, we're supposed to unsimplify it, all right? Square root of a single number. So what you do here is you want to make sure that the number that is outside the root sign is written as a square, all right? So when we do that, basically, we won't change the value of the whole term, but notice what we'll do. So we're going to have 4 squared, okay? And then we're going to introduce the root sign. So you see, this really hasn't changed the value of 4 there, because when you find the square root of 4 squared, we're just going to get 4, all right? Then we are going to then, of course, reintroduce root 3 right there. And so this here can always be rewritten as the square root of 4 squared times 3, or the surd of 4 squared times 3. Of course, notice that this here is the same as having the surd of 16 times 3, which happens to be the surd of 48. And so that there is our answer. So 4 root 3, which is a surd written as a square root of a single number, is of course the square root of 48, or surd of 48, surd 48. Or sum. So we handle the next one. So we are having 5 root 7, of course, which is a surd. And so this is also very easy. Oh my God. This is also very easy. So whatever number we are having here, we're just going to square it, okay? And then, of course, if we square it, notice we are going to have 5 squared, of course, okay, 5 squared in the root, under the root, times the surd of 7, okay, times the surd of 7. And so this here is the same as the surd of 5 squared times 7, of course, rewritten, of course, which is the same as the surd of 25 times 7, which will give us the surd of 175. And so that there will be our answer. Okay, so that's it for this particular class. If you have any questions, if you have any suggestions, you can drop them in the comment section. And basically, let's keep learning from each other. Thank you.